Welcome back to AP Chemistry. This is Chapter 8, Bonding General Concepts, and we are working on AP multiple choice questions. For the first question, determine delta H for the reactor represented above, where each molecule represents 1 mole of that substance. In order to calculate delta H for overall reaction, we need to first calculate the energy that formed two CO2 molecules and 4 water molecules, and then use that to minus the energy that is used to break the bondings between the reactants. So first, we can count that there are totally 8 OH bondings, which is 475, and then we plus 4 CO bondings, which is 800. And then we use that to minus 3 OO bondings, which is 500 kilojoules per moles, and then we minus 2 OH bondings, which is 475, and then we minus 2 CO bondings, which is 800, and then we finally minus 6 CH bondings, which is 400 kilojoules per moles, and then you will get the final answer, which is negative 550 kilojoules. Which of the following has a bent molecule geometry with a bound angle of approximately 120 degrees? So A has 4 electron domains, and 2 of them are lone pairs, which could not be the right answer, and C has 3 electron domains, but there's no lone pairs in it. So it's a trigonal planar, and D has 4 electron domains as well, so it cannot be 120, and the only one left is B. It has 3 electron domains, and one of them is lone pairs, so it's a bent geometry. Which of the following is nonpolar? There are 4 electron domains in A, and one of it is lone pair, so it's not symmetrical. In B, there are 6 electron domains, and 3 of them are lone pairs, so it's not symmetrical as well. And D, there are 5 electron domains, and 2 of them are lone pairs, and the answer will be C since it's symmetrical. Which diagram best represents the shape of SF5- ion? In this ion, there are 2 elements showed up, so we need to count the valence electron of sulfur first, which is 6, and then we need to count the valence electron for fluorines, which is 7. And in this ion, there are 5 fluorines in it, so we times it by 5, and then we will get 35 electrons for that. And we need to pay attention that the ion is -1 charged, so we need to plus 1 more electrons when we add up all the valence electrons, which will give us a result of 42 electrons. In order to get the correct answer, we need to first put electrons around each options. So for A, we have totally 36 electrons, and for C, we could count that there are totally 40 electrons, and for option D, there are 42 electrons around it, and for B, after we put all the dots, we can know that there are 40 electrons around it. So based on what we get previously, the correct answer will be D. Which pair of elements is likely to produce a highly polar covalent bond? In option A and B, Mg and Ln are metals, so what they will produce are ionic bondings with fluorines. And the only 2 options we have left are C and D. Based on the periodic table, C and F are further together, which will produce a highly polar covalent bond. Therefore, the answer will be D. Which pair of elements is likely to produce a nearly nonpolar covalent bond? In this question, we need to focus on electronegativity. First, what we need to do is to mark elements showed up in the options. And in order to find out which pair is likely to produce a nearly nonpolar covalent bond, what we need to do is just to find out which two elements are closer together. So based on what we have on the periodic table, the answer will be D. Which pair of elements is likely to produce an ionic bond? In this question, we need to find out which pairs could produce an ionic bond. So ionic bond is basically the bond created between metals and nonmetals. So first, what we need to do is find out elements on the periodic table. O and F are nonmetals, so they cannot produce an ionic bond. The same with S and N. Li is a metal and Cl is a nonmetal. Ca and Ba are both metals, so they could not produce an ionic bond neither. So the answer will be C. Which molecule is likely to have a measurable dipole moment? What we know about dipole moment is that it's a polar structure, and which is also means that it's not symmetrical. So first we take a look at option A. There are 5 electron domains and one of it is lone pair, so we know that right away it's not symmetrical. And then we take a look at other options. So first we take a look at C. We can see that it's symmetrical. The same with B and the same with D. So we can know the answer will be A. Of the most common ions of the third period elements Mg, Al, P, and S, which is the largest? In order to find out the largest ion, we first need to note their properties. Mg and Al are metals which will lose electrons during the reaction. P and S are nonmetals which will attract electrons. And we know that atomic radius will decrease from left to right, so the answer will be C. The term delta H for the reaction of methane with oxygen. In order to find delta H for the overall reaction, we need to note the formula for that. Delta H equals to the energy form the bondings and then minus the energy break the bondings. In this reaction, there are 3 water molecules and 2 carbon dioxide formed. So we put 3 in front of it, and since we know that there are 2 OH bondings in each water molecules, we times it by 2. We get 470 from the table provided. And then we plus 2 carbon dioxide. We know that there are 2 CO bondings in each molecule, so we also times it by 2. And then we minus 2 OO bondings, which is from the oxygen. And then finally we minus 4 CH bonding. So the final answer will be negative 3,420 kilojoules, which is A. Which of the following best explains the difference in the melting point of magnesium oxide and sodium fluoride? In this question, we're basically focusing on intermolecular forces. Since magnesium oxide and sodium fluoride are both ionic bondings, so what we need to do is just to use Coulombic formula. Since magnesium oxide has greater charges in ion than sodium fluoride, therefore it has a greater Coulombic attraction in magnesium oxide. so the answer will be A. The melting point of the compounds LiF, NaCl, KBr, and CiSi exhibit the following trend. Which of the following correctly explains this trend? The answer for this question is B. The greater radii of the larger ions results the smaller lattice energy, leading to lower melting points. Lithium is in the first group and it has the largest radii. Since lattice energy is decreasing from right to left, so lithium fluoride has the greatest lattice energy, which leads to the greatest melting point. Use the following information to calculate the HCl bond energy. In this question, we're still using delta H equals to the energy formed bondings minus the energy break bondings. In this case, we know the delta H for the overall reaction, so we just substitute it into the formula. And we don't know HCl bonding energy, so we just leave it as 2HCl. And then we minus Cl bondings, which is 240 kilojoules per moles, and then we minus H bondings, which is 480 kilojoules per mole, and then we get the final answer, which is 490 kilojoules, which is C. Which of the following best describe BF3 and NF3? First, we need to figure out the valence electron of each element in the compound. For B, there are 3 valence electrons, and for F, there are 7 electrons, and both compounds contains F, so we also write F on the other side. And nitrogen have 5 electrons. What we need to do now is to calculate the electrons in each substance. There are 24 valence electrons in BF3 and 26 valence electrons in NF3. The answer for number 14 is C, which states that they have different geometry and different shapes. Because BF3 only has 24 valence electrons, whereas NF3 has 26 valence electrons. So we can see that there is a lone pair in NF3 which gives it a spatial shapes than BF3. So they have different geometry and different shape. Which of the following correctly ranks the following species from smallest to the largest ionic radius? Calcium and potassium are metals, so they will lose electrons during the reaction. Sulfur and chloride are nonmetals, so they will gain electrons during the reaction. They are So we can know that sulfur and chloride will be larger. More specifically, we need to know that atomic radius is decreasing from left to the right. So calcium 2 plus is the smallest and the sulfur 2 minus is the largest, which is D.
Thank you for watching, and if you have any more questions, leave a comment down below, and remember to subscribe and like the video.